So good morning. I welcome you to this lecture on big data analytics. In today's lecture, we are going to make a review of HDFS, right? So I'm unmuting somebody. Can kindly unmute.
Good morning, sir.
Yes, Narendra, good morning. Narendra, we want to work with HDFS. What is the first thing that we should do? Kindly suggest.
Sir, in the terminal, we will start the HDFS file system.
What should I do? I should start the terminal.
Click on the terminal, yes, sir.
Okay. So I'm clicking on the terminal. What next?
Sir, start the DFS.
What is that?
Sir, start.
What is that? What are we trying to start?
So we are trying to start name node and data node.
Why? Why are they required?
Because sir, HDFS works on data node and name node.
What is HDFS?
Sir, Hadoop distributed file system.
Okay. So what do you understand by a distributed file system, Rinder?
सर फाइल सिस्टम सर्विसेज हैं जैसे कि
No, I'm asking you, what do you understand by a distributed file system?
सर डिस्ट्रीब्यूटेड फाइल सिस्टम की जो जिसमें हम डाटा डिस्ट्रीब्यूट करके रखते हैं अलग अलग जगह पे नोड्स पे एज इन HDFS.
Distribute. Okay. All right.
Yes, sir.
I'm unmuting somebody else, but there is no response. Yeah, Kushpreet, can you hear me? Good morning. Kushpreet, what is a distributed file system? Yes, Kushpreet? Your voice is not loud, you know. Speak louder, please.
सर उसमें हम जो डाटा है डिस्ट्रीब्यूट करते हैं नेम नोड कैंडिडेट नेम नोड एंड डाटा नोड में.
Okay. But वो होता क्या है? What is a distributed file system?
हेलो सर.
Yeah, what is a distributed file system? So we are not getting a response from Kushpreet. Let's ask. Nikhil. Yes, Nikhil.
Yes, sir. Good morning, sir.
Good morning. Nikhil, what is a distributed file system?
सर डिस्ट्रीब्यूटेड फाइल सिस्टम में हम लोग जो भी फाइल होता है उसको अलग सेव करवाते हैं उसको छोटे छोटे पार्ट्स में और उसका रेफरेंस जो होता है उसको अलग सेव करते हैं.
All right. Not very clear, Nikhil, but I'll take your answer to begin with. Let's ask somebody else.
Good morning, sir.
Good morning, Rahul. How are you?
Fine, sir.
Rahul, we are discussing the distributed file system, the Hadoop distributed file system. So I want to ask what is a distributed file system? How does it work? What is the architecture for a distributed file system? lost Rahul. Yeah, just a second. Yeah, Rahul, you can unmute yourself again.
हेलो सर।
Yes, Rahul.
सर इसकी आर्किटेक्ट में सर एक स्कैडी नोड होता है, नेम नोड होता है और डेटा नोड होता है। नेम नोड के बीच में सर मेटा डेटा होता है और उसमें सर डेटा नोड के जहाँ पे ट्रैक होता है, जहाँ पे डेटा स्टोर होता है, उसकी इंफॉर्मेशन होती है।
Okay, but
और फिर जो
I'm asking you like how data is stored. I'm asking you about architecture. What is the mechanism for storage of data? Like suppose I need to store a file in my distributed file system, right? How it is
यस सर,
stored? How it is stored?
सर वो रैक्स में होता है ना, रेप्लिकास में, डेटा नोड्स में।
You're not clear about it. You're not spelling it out clearly. आपको पता है, but the answer is not very clear. Let's hear from
कंफ्यूज
somebody else. All right, Rahul. Thank you.
नो प्रॉब्लम।
Yes, good morning, sir.
Good morning. Yes, Ritika, what is the architecture for a distributed file system like Hadoop?
So in distributed file system, the file is split into blocks and then it is stored in multiple nodes, like different racks.
Okay. What is the
Yes,
idea
according
behind?
to the replicas. Yes.
So, what is the idea behind splitting the files into blocks? Why should we split the files into blocks?
So we split it so that the access can be faster
Mm-hmm.
and to increase the seek time.
All right. One answer could be that we are dealing with huge files, so it's not possible to store huge files. So much space is required on a single machine. So the files are
Yes,
split
sir.
up so that they can be stored on different nodes across a cluster, right? And what is the
Yes, sir.
replica? What is the replica placement policy for a file in HDFS, for a block in HDFS?
So it could be like if the factor is 3, then 2 nodes should be placed on the same rack
Mm-hmm.
and 1 node should be placed on the another rack.
Or rather, 2 blocks should be placed on 2 nodes in one rack and 1 block
Yes,
on
sir.
1 node in another rack. That is the replica
Another rack.
placement policy. Okay, fine. Okay, so let's come back to Rohit now. Yes, Rohit.
Yes, sir.
Now, Rohit, we have understood what is a distributed file system. I want to work with the distributed file system. Okay. For that, I've opened up my terminal. What should I do here now? How should I start working with my distributed file system?
सर फर्स्ट तो Hadoop को फॉर्मेट कर देना।
Oh, that has all been done. Hadoop has been installed, right?
Oh, then we can go with start-dfs.sh.
And what is that, Rohit? What is the start-dfs.sh? What it will do?
Sir, to start the distributed file system services.
Okay, so to start working with our distributed file system, we must
Yes, sir.
start the some daemons or some processes or some services of
Services.
the distributed file system. So what are those services called, Rohit? What are their names?
Sir, name node, secondary name node, resource manager,
I'm talking
data node.
I'm talking about a distributed file system services, okay? Not the yarn services. So spell out the distributed file system services.
Name node, data node, or secondary data node.
Secondary name node, right?
Name node, sorry.
Yeah. So name node, data node, and secondary name node. That's perfect. Let's begin them. Let's start them. And let's ask somebody. Okay. I've asked somebody to unmute. Kindly unmute yourself.
Yes, sir. Good morning, sir.
Good morning. Sarika, would you please explain the meanings of these daemons, processes, or services? Like you can see 3 services, processes have started. The secondary
sir.
name node, and data node.
Yes.
What is their purpose? Explain purpose of each one of them.
Name node for storing metadata.
Okay, and what is that metadata?
Sir, information about data.
Hmm?
Information about data.
What sort of information? What information is that?
Some metadata.
What is that? What does it contain?
The admin machines.
Okay, what about data node?
And this store actual data.
And secondary name node?
So a number of a block for name node and
Okay.
Good morning, sir.
Yes, good morning, Mani. Mani, would you please explain these three processes?
Yes, sir. Yes, sir. First, name node daemon just store the metadata about actual data, and data node will store the actual data which we are storing through files, and the secondary name node actually do the merging of the FS image and edit logs.
Okay, fine. Thank you, Mani.
Yeah,
That's good. That's a good answer. So Mani said that name node is storing metadata. Data node stores actual data. Secondary name node helps the name node by merging the FS image and edits. Okay. So let's ask somebody what is this FS image and edits. Okay. So somebody can unmute. I've unmuted somebody. Yeah. Yes, Prince. Go ahead. What is this FS image and edits?
Name node, there are two parts. One is FS image and edit logs.
Prince, your voice is not clear.
So in name node, there are two parts, FS image and edit logs. FS image records what it says.
Prince, your voice is not clear at all. There's a lot of disturbance, so I've muted you. So I've asked somebody else to unmute to explain the FS image and edits.
Good morning, sir.
Yes, good morning, Mridul. Mridul, what is this FS image and edits? What files are, what are these files?
So the data stored in the name node, it stored in the FS image. It makes the FS image.
Okay. And what is edits?
Edit the changes we made in the cluster.
Okay. And what is the purpose of joining them?
So to show to combine the HDFS with the cluster.
Not a proper answer, Mridul. You're not updated about it. Okay. Let's ask Niladri.
Yes, sir.
Answer this question, Niladri. You're taking too long to answer.
Yes, sir.
Now, please answer.
Sir, it contains the directory of the data in the data nodes in the form of inodes.
That's not what I asked. Okay, I'll ask somebody else. Thank you.
Good morning, sir.
Good morning, Share. Share, would you please tell what is the idea behind merging FS image and edits file?
So, to merge to get the so HDFS based on share for nothing approach. So to combine all the data, so better computation.
No, not a exact answer, I would say. Let's ask somebody else. Let's ask Yash Udewal.
Good morning, sir.
Good morning. Yash, how are you now? Fine?
Yes, sir.
Okay, fine. So could you please tell why should we merge these two files?
Sir, when we are doing some modification in some files,
Mhm.
so that is being stored in edit logs,
Right.
and the modifications are stored in FS image. So when the modification is
No, no,
completed, we merge.
I don't think that's a correct. You started with the correct answer, that whatever modifications we make in our cluster are recorded in edits file. Then what
Yes, sir.
happens? Then further?
Then if the modifications are like done, then both the files being checked that if there is some sort of error or not.
No, no, no,
And
no,
if
no,
everything is
no.
done,
I'll stop you. No, that is not the correct answer. Okay, let's ask one last time. Yes, Ritika.
Yes, sir.
Your answer,
So,
Ritika.
so edit log contains the changes which we have made to the file structure or in the DFS, and FS image contains the complete directory structure of our HDFS. So there is we can say there is a time period for which all the changes remain in the edit logs, and after that interval, both the files are merges and the changes are made permanent to the directory structure.
Okay. So just to keep our cluster working at a good speed, we don't record the changes that are happening in our cluster directly in the FS image file, which is the file system image, which is a permanent file. So we record whatever changes occur in the cluster, we record it in the edits file. And after a fixed interval of time, which is known as a checkpoint, which is 3600 seconds or 1 hour, both the files are merged and we get an updated FS image, and the edit file is blank. And we could also set up a property in which whenever the size of the edit file reaches a threshold, we can also merge these two files. Okay, that is the idea behind. And our secondary name node is the process which is responsible for this merger, and it sends a HTTP request to name node for requesting for the merger, and then both these files are merged and we get an updated FS image file. All right, thank you very much to all of you for your answers. I hope now you are clear why we merge FS image and edits file, and what is the idea behind recording the changes in edits files. Now let's go further. Now if we need to work with our file system, okay, so we are basically dealing with two types of file systems. One is where we are currently, where you can see the screen. So if I use a list command here, okay, I'm using a list command here, I can see all the files. Okay, so this is my local file system. This is my local file system, the Ubuntu file system. Okay, which is basically your ext3 or ext4 system with a small block size, as you know. And the second one is our distributed file system, the Hadoop distributed file system, in which we store files by splitting them into blocks, and the blocks are stored on data nodes or nodes. And the size of the files which are stored in HDFS is huge. So that is why we can split them up into blocks. We can pick up a block size as per our choice. The default block size is 64 MB or 128 MB. Both, we go with both of them. Ideal would be 128 MB, and higher the block size, better would be the pace at which you can read a file. The basic idea in data analytics is obviously to read huge files at a streaming pace. All right, so that distributed file system architecture helps us to do that. And the idea is not to write. There are not many writers. Only once the file is stored in HDFS, then most of the times we are happy to just read the file at streaming pace and to do analytics. Okay, so remember, we are dealing with two file systems: the local file system, which is right there in front of you, and the distributed file system. Okay, and distributed file system contains the files split up into blocks, and blocks are replicated across data nodes. This replication is done so that the availability of the files or the blocks is there all the time, and if some node goes out of order, then you still have access to that particular file on some other node. And when we talk of HDFS or when we talk of Hadoop, we know that a Hadoop cluster is a combination of heavy duty or admin machine and thousands of commodity machines, that is machines which are prone to frequent failure. Okay, so that is why they are there in large number, so that if a few of them go out of order, the work on the cluster does not stop and the availability of data is always there, right? So before I go further, let me take a quick poll with you all. Okay, so the poll is there in front of you. Last 10 seconds now. Last 5 seconds. Ending the poll now. Sharing the results with you. So 26 of you have given the correct answer, 90% of you. Who has answered init-dfs.sh? Can that person raise the hand? One person has answered init-dfs.sh. Kindly answer, who is it? All right. Two people have answered start-dfs. Who are they? You can raise your hands, no problems. We can discuss so that you can understand what's wrong with those answers. The correct answer, of course, is start-dfs.sh. Okay. And to see the status of your services, we use this JPS command. Okay, so we have used this command to start the distributed file system services, start-dfs.sh. And to see the status, we use the JPS command. Okay. Once again, I'm going to use the list command here for you. So list, ls command is a list command. Most of your HDFS commands are similar to your Linux or Ubuntu commands. Okay, so majority of them are, they work on the similar basis. So if you have a good knowledge or a good working experience of Linux commands, which you people have learned in the previous semester also, and in the current semester also you worked a lot with these commands, then you would be good with HDFS commands, right? Now, how do we use the HDFS commands? Raise your hands, please, to answer this question. How can we use a HDFS command while we are at this prompt? How to use the HDFS commands? You can raise your hands, please, to answer this question. Okay, many people have raised the hand. That's good. So let's ask Shaurya.
Good morning, sir, again. Sir,
Yeah.
Hadoop for Hadoop system, FS command I use. Hadoop FS.
Yeah, very good. So we use this Hadoop FS command, which stands for Hadoop File System command. Okay, thank you. You can lower your hands. As soon as one question is answered, you can lower your hands, right? So that again, we can ask you to raise it. Then Hadoop FS, this is the command beginning, stands for Hadoop File System command. Or we can also use, we can also use this command. Both will work. HDFS DFS. Okay, HDFS DFS. Hadoop Distributed File System, Distributed File System. Okay, so but most of the time we can go with this, our Hadoop FS command. Okay, Hadoop FS followed by your HDFS command. So for example, if I want to list all the files which are present in my distributed file system, I will begin the command with this, and then instead of ls, I will write a -ls. Okay, so all your Hadoop commands, they begin with a hyphen. So this is Hadoop FS -ls, and then I would give a path from where I want to list the files. Okay, suppose I give this path. This obviously is the symbol for the root. So this command, I am trying to list all the files which are present in the distributed file system in the root of the distributed file system. So if I hit enter here, you can see all the files which are present in the root of the distributed file system. Okay, so you can see here some 10 characters are here, right? These are the file permissions. Okay, the first character indicates whether you are dealing with a file or a directory. So if the first character in the listing here is a hyphen, then it's a file, and if the first character here is a D, then it is a directory. Okay, that is a distinction. And the next 9 characters, okay, who will explain the next 9 characters to me? That is, you can see for this file, the first file, rw hyphen r hyphen hyphen r hyphen hyphen. What is the meaning of these 9 characters? You can raise your hands to answer this question. Okay, 2 people have raised hands so far. 3. Okay, Yash, Ritika, Nikhil have raised hands. Shaurya also wants to answer. Okay, let's go with Nikhil. Nikhil, you can answer this question, please.
Read and average information to the
Nikhil,
owner
your
group
voice is
and
not clear. No, your voice is not clear. So let's ask Yash.
So these stand for the permissions. The first 3 stand permissions for the user.
Okay.
Then the next 3 is for the group
Okay.
to which that user belong.
Right.
And last 3 is the other users.
Okay, so first 3 for the owner or the user, the next 3 for the group to which the user belongs, and the last 3 for people who are outside the group, others. Okay, and what are the meanings of these permissions? RW hyphen, what is that? Yes.
So read, write, and execute.
Okay, read, write, and execute. So right now, the user has the permission to read and write this file, right? And
Yes,
others, the group members and the others can just read this file. That is what is the meaning. Fine. That's fine. So these are the meanings of these permissions. Okay, Nikhil, you can lower your hands, please. Thank you. And then while I've listed the file here, one distinction should be there, that this path here, this slash, whatever path you mention, files would be listed from that path. So whenever you're working in any operating system, any file system, you must be very clear about the path where you are. Okay, for example, if I just want to see where I am right now here in the shell, where I am located, so I can just print this command. I can write this command, right? Present working directory or print working directory. So you can see right now I am in the folder home HD user. That is a default folder for a user in Ubuntu, right? The username which is under the home folder. So this is home HD user is the folder where you work. So you can always change this with the cd command. For example, if I just do here, say a cd and then 2 dots. Okay, so I go back one step. Now I am in the home folder. If I again write here cd 2 dots, then I go to the root of the local file system. Okay, and you can if I just you can see the prompt also now. Okay, you can see the if you are in your home directory, there is a tilde sign. Okay, so to reach your home directory from any place, just type cd. You can see the tilde, that is your home directory. So if you see a tilde, that means you are in your home directory. Okay, and if you want to list the files in detail in the local file system, you can use a ls-l. Okay, the long listing is there. Okay, so I was discussing this command with you. I'll be discussing each and every command in quite a lot of detail, so you can kindly note whatever things you have missed previously, so you can have a good look at it now. So what happens if I just write this hadoop fs-ls? I don't mention any path. I'm not mentioning any path where to list files from. So the first thing is, will it work? Yes or no? And if it does, what it will display? Raise your hands, to answer this question. Yes, Rahul, go ahead.
Yes, sir, it will work.
Okay, what it will display?
Default path. User, HP user, sir.
Okay, so it will list the files and directories from your default path, that is default path for HDFS, and that is the folder user HD user. Okay, so there is a default user folder in HDFS. Below that is the HD user folder, or whatever name you have created your cluster with. So it is /user/HD user. So if I just press enter here, you will see the files from that folder. Okay, you can see now these files are present in your user HD user folder. All right. If if you are not sure whether, because there is no listing out here, it's just list the names A1, A111, Deepti, dot trash, like this. Okay. So if you want to be very clear that we are, in this path, you can give an explicit address here, explicit path here, to see whether, these are the same files which I'm talking of. You can see the explicit path now. Okay, user HD user dot trash. So we are listing, when we write this command, without specifying any path, it goes to the path user HD user by default. Thank you, Rahul.
Thank you, sir.
Okay. So we have talked about the path. Now I want to start by web UI. This is the command line which we are using to, access our cluster. Okay. So if I want to use the web UI, what I should do? If I want to see the web UI, web user interface of my cluster, what I should do? Kindly raise your hands to answer this question. See, today we have an interactive session, so it should be, a communication both ways. So kindly you can open up your notes or whatever, so that we can have a good discussion. Okay. So Ritika wants to answer. Yes, Ritika.
So we can go to any browser like Mozilla and then type the localhost :
Okay.
9870 for 3.x.
Right. So localhost 9870 for 2.x. What it is?
54. I don't remember as such.
Okay. Somebody can tell for 2 dot. Prince has raised hand. Okay. Yes, Prince.
50070.
Yeah, 50070. That's right. For a 2.x, Hadoop 2.x series, we would write here localhost : 50070. And for 3.x, that is version 3 and onwards, it should be localhost 9870. Okay. So we get this web UI here. Okay. And from here you can see the information about your cluster, about data nodes, about snapshot, the startup progress of your name node. We'll come to it again today. Now to browse the file system, you go here, which is already there. We have picked that up, but in utilities you can click on browse the file system. So it will list here. It will show you your the root of the distributed file system. You can see all the files in the root. So if you want to go to, say, the default folder, the user folder, then it's here. You can click on this user folder. Within that you have a HD user folder. Okay, so all the files which we listed, we were listing from here. You can see, I'll just show you this thing. You can see it's trash, A1, A111. So that is being listed from here. Okay, all the files are being listed from here. Okay, that is what our default folder is. And even if you don't specify it, as you see it here in this command hadoop fs-ls, even then it will go to that path. So whenever we don't mention any path in our commands, that means we are referring to the default path, that is user HD user in case of our cluster. All right. Let's see now how we can create a file. Okay, so let's create a file here. So this is how you can create a file. You can also create a file using an editor. Okay. So Diwali is around the corner, so this could be a text. Then you can press Ctrl D to save. So I've just created a file with the name as Ritika. To display its contents, you can use this command cat Ritika. So you can see the contents of this file. You can also create or edit this file. You can create a new file or edit this file using some editors. There are many editors. VI editor is there, gedit is there. nano editor is there. Okay, so if I just write like this, okay, then this should be opened up in an editor. You can edit it, or whatever you want to do with that. Same is the case with our nano editor. Okay, so you can use these editors to just modify or change your files. Okay, once this file has been created, obviously our next task is to work with the HDFS commands. So let's begin by transferring a file into our HDFS. Okay, so which command can we use for that? Kindly suggest which command or commands we can use for that. Kindly suggest that. Raise your hands. Yeah, that's good. Many people have raised hand. See, we are reviewing and we are learning again whatever we have missed previously. Let me just look for somebody new. I don't see any new names. Okay, Ritik is a new name here. Yeah, yes, Ritik.
Sir, put command.
Okay, is there only one command, Ritik? Only put command can be used, or are there other commands also for this task?
For putting the file into the HDFS?
Yeah, for transferring a file into HDFS. You've said put command, that's correct. Any other command we can use?
Sir, I think the put is only the command.
Okay, let's ask somebody else. Your answer is correct, but let's ask somebody else whether we have some other command for it. So
okay, sir.
We'll ask. Okay, many people are there. Rahul has answered. Okay, let's ask Shaman Jung. Yes, Shaman.
Copy to local is also a command to copy files and folders from local system to HDFS.
Yeah, come again. I think you are giving a wrong command.
Copy from local.
Yeah, copy from local is the right one.
Yes,
Okay, so
copy from local.
Copy from local. That's correct, Shaman. Good, thank you. So we have these two commands. Kindly have a look on your screens. Okay, we have these two commands: copy from local, and we have a put command. Two commands are there for transferring a file from your local file system into the distributed file system. Okay, so let's use each one of them. Let's first copy this file Ritika using the put command from our local file system. You can see the file is here. If I just list, I see all the files. Okay, but if I just want to see whether Ritika file is there or not, I can do it in many ways. If I know the full name, I can write the full name. I'll see the file is there. If I can use some wildcards or some globs. Okay, so I can use something like this. I'm saying list all the files beginning with the string RIT and then a star. Star would mean anything after RIT. So it will also list Ritika. I can also use something like this. Okay, I'm looking for all files which have the first three characters as RIT and next three characters could be anything. So it will again list this. If I write this command, will it list the file Ritika? Can somebody tell me? If I use this command ls space RIT 2 question marks, will it list the file Ritika? Yes or no? Raise your hands please to answer this. Okay, let's ask Mani. Okay, let's ask Shaurya.
So no, so it will look for two characters RITIK, not
Okay.
last.
So we don't have any, there's no such file. You can see I've pressed enter. It is looking for a file with a length of 5 characters in which the first 3 characters are RIT and the next 2 characters could be anything. So like this you can use other globs also. Okay, we have seen how we can specify a range also in file name. Okay, all right, sure, thank you. You can mute yourself. So let's transfer this file now using the put command. Hadoop put. Then you see how do we write the put command? First the put command, then the file or the files which need to be transferred. So I can write here RIT star. Okay, this would be good for it will transfer all the files beginning with RIT. Okay, and then a path where I want to transfer. So if I just don't mention anything here, obviously this file Ritika will go to the folder user HD user. Okay, so let's do that. So I've transferred this file into the user HD user folder because I didn't mention anything after RIT star. Okay, so let's go there. Let's go to user HD user and let's refresh it. Okay, so I've refreshed it, so you can see the file Ritika, right? You can see the file Ritika here, right? Similarly, if I use this command put and I use a slash here, that means now I want to transfer this file into the root. So this would be transferred now to the root of HDFS. So let's go to the root of HDFS. This is the root, and you can see the file has been copied here also. You can see that. Okay, the file has been copied here also. And see also that for our cluster, the block size is 2 MB. We have configured it to 2 MB, and the replication factor is 1. Kindly keep this in mind for our future, today's session. Keep these two things. The replication is 1 and the block size is 2 MB. So let me ask you a question. I'll repeat this command. What will happen? Remember, the file Ritika is already there in the root. I'm again trying to go ahead with this command. What will happen now? Will it allow us to, overwrite the file? Yes or no?
No, sir, it won't allow.
It will say?
Sir, already exists file.
So if we try this, it will say file already exists. Okay. Can we do it? Overwrite it?
Yes, sir, by using flag -f.
By using a parameter or a switch, not a flag. Okay. Using a parameter or a switch -f. Okay. So this will now overwrite the existing file Ritika in the root. Okay, this works. Right. Thank you, Mani. Thank you.
Thank you.
Now let's use this file, use this command, copy from local. We have just used put. Let's use copy from local. And let's copy this file checksum. Okay, there's a file checksum. Let's list it. Okay, so I've listed the file checksum. You can see I want to transfer this file into HDFS. So I'm using the command copy from local. See how to write it. Every word, first character is capitalized except the first word. Okay, copy in all lowercase, and the subsequent words, every first character is capitalized. So copy from local, and then the file name, you can use this CHE, and then you can use a slash. So with this command, I'll transfer the files beginning with the word CHE, okay, into my distributed file system. So transfer the file. So it already exists. Okay. So let's see whether, we have a switch copy from local, we have a switch -f, or is it only with the put? Yeah, it's there in copy from local also -f. So I've forced the writing of the file checksum into the root of the distributed file system. Okay. Time for a quick poll for all of you. So a quick review. Okay. Answer it quickly. Okay. It's an easy question. It's in front of you now, the poll. Limited time, 15-20 seconds. Okay, 5 seconds now. I'm sharing the results with you. 94% of you are correct. It is a put command. We just discussed it. Two people still are saying copy. Can I know who those people are? I'll obviously have a look at it later on when I download the poll results. Who have answered the copy as the answer? Kindly raise your hands. Some two people have answered copy. Who are there? Okay, they are not willing to talk. All right, no problem. Similarly, to do the reverse, okay, we have the get command and the copy to local command. That is to transfer a file from our distributed file system to our local file system. We have the get command or the copy to local command. Okay, so let's have a look here. We just copied a checksum file into our cluster. I will remove this file from here. I'll remove the checksum file from my local file system. So you can see now there is no file checksum here. Okay. Now I'll copy this file from the root of the distributed file system. So I'm doing the reverse process now, copying from my distributed file system into my local file system. So I told you it's a get command is there. Okay. Instead of put, we have a get command here. Okay. So get, what should I write here? Should I write the file name or should I write something else? If I just write it here like this, I'm writing hadoop fs -get checksum. Will it copy the file from the root? Yes or no? Raise your hands. If I write it like this. A relevant question. If you don't understand the file system, you'll do some mistake. Okay. Let's try somebody else. There are so many other students sitting. Let's see what they are doing. So let's talk to roll number 274.
Good morning, sir.
Hanji Upinder. Kindly answer this question, Upinder. Will this work? Will this copy the file from the root? Yes or no? That's it.
No, sir.
Why?
स्लैश आना चाहिए.
कहाँ पे? यहाँ डाल दूँ?
Last, yes. मैं space डालते.
यहाँ पे डालूँ? Okay.
Yes.
ठीक है. Let's ask Ritika. Yes, Ritika.
So it will look for the file in the home directory.
Yeah, if
So
we
we
write
should-
like this, yeah.
So we should write /checksum.
So we should write the path. This
Yes, sir.
now is the correct one. We are saying that there is a file checksum which is under the root. Okay. And if I just write like this here, okay, it will, I'm not mentioning any path, so it will be looking for this file in the user HD user folder. Okay. So let's use this. Okay. And if I repeat this command, let's say what it says. It says file exists. So if I go with a -f here, let's see whether it works. Let's force its writing. It should work, I suppose. Yeah, we can force again by this. And we can use copy to local also. Let's check that also. Okay. This will also work. So I hope you understood the commands. Copy to local, copy from local, and put and get. 4 commands we have discussed about file transfers. Okay. There is another command. Suppose let's say let's check the distributed file system first, or let's delete this file again, the checksum file. Okay, I've deleted the checksum file. I've used a dangerous command actually. I didn't delete checksum. I may have deleted all the files beginning with che. So usage of wildcards like star and question mark is a tricky thing. So be very careful while you are using these with your remove or your remove directory command. Be very clear about it. Then this file checksum is not there now in our local file system. I want to move this file now. It is present in the root of the distributed file system. I want to move it from there, okay, to my local file system, so that it comes here and it is moved from there. It is not there. Which command I should use? Raise your hands, please. To move the file checksum from the root of the distributed file system to my local file system, which command I should use? Rahul wants to answer. That's a quick hand raised by Rahul. Yes, Rahul.
सर एरर थ्रो करेगा.
कमांड बोलो पहले.
hadoop fs move to local root file name.
क्या एरर आएगा बताओ.
yet implemented sir ऐसे कुछ कर
अच्छा ठीक है, you know it, huh? So move to local, this feature is not yet implemented. You cannot move a file from your distributed file system to your local file system. Okay, so this won't work. It would say feature not implemented as yet. Okay, move to local is not implemented in clusters. Okay, what about this, Rahul? If you are with me, what about this? Will this work?
yes
Okay,
sir
this will work. Okay, we can move a file from the local file system to our distributed file system. All right, good.
thank you
Let's now talk about directories. We just talked about files. Let's talk about directories, and then we'll talk about the block size and the replication, you know, how the files are being stored in the cluster. Okay, so I want to create a directory. Obviously I can write something like, I can say, I give like this, mkdir Rahul. Okay, so this directory is created. If no message is there, this directory is created. Where this directory is created? Which path? Is it under the root? No, it is where you currently are. So you currently are here. Okay, so Rahul directory, if you want to change, you will see that it is under the home HD user directory. Okay, so let's come back to home. If I create this mkdir money, let's create a directory like this. So, and let's ask money itself, because it is about him only. So let's bring him into discussion. Money, you can unmute yourself.
Yes, sir.
Money, this directory would be created in your name below the root.
No, sir, because we don't have a permission.
Okay, fine. So we don't have a permission. Okay. Remember, while a user has a permission below his or her home folder only. So you can create anything below HD user, not anything above it. Will this work? Let's see. Will this work, Money?
No,
No,
sir.
because now we are trying to create something in the home directory. Even we cannot do that. So any RXS is HD user and below. Okay, remember
yes sir
this thing. Okay, fine. Thank you, Money.
thank you
All right. So now same is with our Hadoop FS. You know, in distributed file system, you can also create a directory. Let me create a directory, say Anju. Okay. So I created a directory below the root. I've given the path. I've created a directory below the root. Let's see whether the directory has been created. Let's see whether Anju directory has been created here. So you can see the Anju directory here. And remember, the replication factor for directories is 0 and their size is also 0. Okay, only files have sizes or replication factor. Directories are just a storehouse for your files. Okay, and the block is also 0. You know, they don't occupy any space also. All right. So another thing I want to discuss with you is if I write it like this. Okay, so you can raise your hands to answer one question. If I use this command, will the directory Anju be overwritten, or what would happen? Where would the directory Anju be created? We have discussed this thing many a times today, so an easy answer I would say. Can we create a directory like this without specifying any path? Okay. Yes, Ritika.
Yes, sir.
Okay, we can create. And where it would be created?
Below /user/HD user.
In the default folder of the user, that is user HD user. If you go here, you can see the Anju directory here, right? There's Anju directory here. All right, fine. So let's now create a directory structure. You know, if I use this command, okay, I'm trying to create a directory Z3 which is below Z2 which is below Z1. Okay, and let's go to root. There is no directory as, you know, Z1 here, you can see. Okay, so what will happen with this command? Raise your hands, please. Will it allow me to create the directory? Many people are again raising hands. Let's look for somebody new. Okay, let's hear Prince if we can hear him now clearly. Yes, Prince. Yes.
Sir, it will not make a directory. We have to mention a -b to make a parent directory.
Oh, if the parent directories are not there, that's correct. You know, if you're trying to create a directory hierarchy structure, so for Z3 to be created, Z1 and Z2 must be present. Okay. If they are not present, okay, obviously it will give you an error that Z1, Z2 does not exist, something like this. Okay. So Z1, Z2 is not there, so Z3 cannot be created, right? So if you need to create all the directory structure by yourself, just include a -p for a parent, you know, a parameter, okay? Then you will see that this directory structure is created automatically. You can see here, if you just refresh your browser, you will see that the directory structure has been created, okay? Or has it not been created? Yeah, let's see the refresh this thing now. You don't have the directories? Let's check. Where are we missing? Okay, we have a longer listing now, so we are going to second page. Yeah. So we have a Z1 directory here. Okay. Below that there is a Z2 directory. Below that there is a Z3 directory. That is with the -p switch. So let's just remove a file so we can work easily. I'll remove a few. Remember, if we delete something from here, it is gone. Okay, forever. So I'm deleting it forever. I'll just remove a few files from here so that we have a shorter listing of files. Okay, just stay with me for some time. And we require this for our pig, pen department. Mary, again we require for your MapReduce learning. I'll remove this file also. Okay, I'll remove this also. I'll remove all these files so that I can show you something good. I'll remove this Shakespeare file also. Okay, ये भी निकाल देते हैं. Let's remove these files also. Okay, good now, right? So let's discuss about the blocks now. Okay, so if we transfer a file, you can see the file shakespeare.txt to the root. Okay, I'm transferring a file shakespeare.txt to the root of the HDFS. Remember, the block size in HDFS in our cluster is 2 MB. So let me first list this file. Let's have a longer listing so that I can see the size also. We have a size of approximately 5.5 or 5.4 MB for this file. Okay, remember, this file shakespeare.txt is of size 5.4 MB around. Okay, so if I transfer this file, fs hyphen put Shakespeare to the root, I'm transferring this file to the root of HDFS. It is not there right now, but once I update this cluster, you will see that the file is there. Okay, you can see the size is 5.32 MB. So my question is, how many blocks for this file in our cluster? And then we'll talk further about those blocks. Okay, how many blocks for this file? Okay, meanwhile I'll just remove a few more things. I want to show you something good. Okay, yeah, keep on raising your hands. I'll come back to you. Narinder Pal can answer this question.
Sir, 3 blocks.
And what are the sizes of those 3 blocks, Narinder?
सर फर्स्ट 2 होंगे वो 2 MB के एंड जो लास्ट वन होगा वो जितनी बाकी बचेगी 5.3 से.
ओके, मैं ये भी सब डिलीट कर रहा हूँ एक सेकंड ताकि शेक्सपियर फाइल फिर से ले आएंगे. योर आंसर इज करेक्ट नरेंद्र, थैंक यू. आई एम मूविंग ऑल दीज फाइल्स को फिर कॉपी कर लेंगे, है हमारे पास फाइल्स ये. ऑल राइट, let's copy it again and let's come to this. We see when we refresh it, you can see the file will appear. And let's see, like Narinder answered that this file will have 3 blocks. So let's click here on the file name and you can see the block information here. Okay, there is something known as a block pool ID, you know, the pool to which all the blocks belong. And then there is something known as a block ID. So every block has a identification number, that is a block ID. You can see block 0 has an ID ending with 303, block 1 ending with 304, block 2 ending with 305. So block 0 has a size of 2 MB, this is 2 MB, okay. Block 1 again 2 MB, and block 2, the remaining 1.32 MB is there, right? This is the block size. Now, where all these blocks are stored, that is my next question to you. Where can I see these blocks in my cluster? Can I actually see these blocks as files? Because here I'm seeing the block ID and all, but obviously if the data is there, you know, in these blocks, then they should be stored somewhere. So the question is where they are stored, how we can access them, how we can see them. Okay, Rahul has raised the hand first, good. Only one person can answer this. Yash also wants to answer, that's good. Money, 3 people have answered. Okay, let's ask Ritika also. Yes, you can answer this.
So we can go to the path in a storage, like we can go to the computer, the path where you have installed data node and name node.
Okay, what is that path that's there in front of you? Kindly help me.
So then user, local, then Hadoop store.
Very good. So while we were configuring our cluster, we put, you know, the name node, we created the name node and data node directories, and we put it under this Hadoop store folder. Okay. Then there is a HDFS folder.
HDFS.
Then there is a data node and name node. So obviously we say that the blocks are written on data node. So we go to data node, then we go to a folder, current. Okay. Then the block pool that you saw there, below that all the blocks would be there. So go to current. Okay. Now we have two folders here. One is a finalized and one is replica being written. Okay. So we'll go to the finalized folder. There is a subdirectory 0 here. And there are so many other subdirectories. So let's click on subdirectory 0. We don't see anything here. Let's go to subdirectory 1. There's nothing here. We just remove all those things. So here you can see the blocks. Okay, here you can see the blocks. I'll go to your cluster again to help you out. Kindly have a good look at this so that you can understand. See our block numbers here, the block ID. Can you see the block ID here? 107376. Okay. Its size is 2 MB. Okay. Let's look for this block ending with 303 in our computer. Can you see this block here? That is the block that is mentioned there. BLK underscore, this is the concerned block file, 303. There is an associated checksum file also, which begins with the same 303 and then it's got a .meta extension. Okay. So if you are good in calculations, okay, I give you a good chance. I am telling you what 2 MB is, it's here. Okay. Can you tell me the size of the checksum file here? Can you tell me what is the size of this meta file here? This file 303_5479. So let's have a quick check. This is 2 MB. This is a 2 MB, the number of bytes. So can you explain what is the size of this meta file here? I'm waiting for your answers. You can raise your hands to answer this question. I'll ask you how you've calculated, okay? This should be a good question for all of you. I'll give you 30 more seconds, not more than that. You can use your calculators, you can use your computers. What would be the size of the checksum meta file? Ritika has calculated. First, Prince has calculated. Okay, 2. Okay, let's ask Ritika. Ritika, I don't know the answer. Okay, yeah.
It will be 16 KB. That is 16,391 bytes.
Let's check. Very good. 16,391 bytes. Very good. Perfect answer. So can you explain to the class how you've done it? Yes, Ritika, can you explain how you've done it?
Yes, sir. So the file size was 2 MB. So I split it into bytes and then divided by 512.
Okay.
That is, for each 512 bytes, it adds 4 bytes to the meta file size.
Okay.
So after dividing by 512, the answer was 4096. So I multiplied it by 4. And then I got 384.
Okay.
So plus 7 bytes for each meta file. That is default size.
What is that for? That part is missing, Ritika. That is not the correct answer.
Yes,
okay.
sir.
Wait, the final part is not correct. Okay. Somebody else can answer this. Okay, I'll explain it to you. Let's first look for a calculator here so that you can see. Okay, look on your screens now. You can see the calculator. Okay, you can see the calculator here. So it is 20, what's the size? 2097152. Okay. 2097152. I divided by 512. Okay, I get this 4096. For every 512, 4 bytes are added. So I multiply it by 4. Okay, plus there is a checksum header which should be of 7 bytes. There is a checksum header which should be of 7 bytes. Okay, if it is less than 7 bytes, that means the file is corrupt. So the header information is of 7 bytes. So that is 16391 that you get, that you see the size of the meta file here. Okay, 16391. That is how checksum is calculated. Okay, so this is one thing, right? So obviously you would ask, what is this RBW? Okay, this is finalized is where your, correct, error-free blocks are stored, finalized block, and within that there are so many directories, subdirectories. We don't know how they are, arranged. It will automatically, for every, this thing, incoming blocks, it will keep on creating subdirectories as per the architecture. Okay. Now, while the blocks are being written, while they are being, verified, they first come into this folder RBW, which means replica being written. Okay. Right now it is empty. Okay. But the files first come into this folder. If their checksum is all right, then they are moved to the finalized folder. Okay. Let's see this thing. I'll help you see this thing here. Here I have I am in these two folders. So I'll show you how the files, the blocks, they arrive here and then they are shifted here. And once the file is written, this again becomes empty. Okay, let's see this. So let's list our this big dot, this file, big file that we have. Some problem here, big hyphen 0.16.0. This is the file. Okay, I'm going to list it for you. This is a big file. The size is around 170 MB. Okay, so we'll have a large number of blocks. Okay, so if I shift this file into the HDFS, the blocks would first arrive here in the RBW folder. And from that, they would be shifted to the finalized folder. I'll open the RBW folder for you, which is empty now, right now. And when I copy this file, let me copy the file. Let me put the file into the distributed file system. That is pig hyphen this file. I'm going to put it in the root of the distributed file system. Okay, I'll put it, and obviously the blocks would be written. The file would be split up into blocks. They would be written. They'll first go to this RBW folder. So I'm putting an enter here. The process has started. See the blocks now. Okay, and see the file. You can see the blocks coming here, being verified. The checksum is okay, and they are going to the finalized block. And once the process of writing is over, they will be, this RBW folder would be blank. So you can see the file has been written here. You can look for, update this, and you can see that the file has been added, right? You can see the file, this, and you can see how many blocks are there for this file. We have got 85 blocks numbered from 0 to 84. Okay, fine. This is how, checksum and how these folders are all laid out. Okay, let's see if we have some poll for you guys, whether we have reached that particular portion. Not yet. Okay, let's have a quick question. Yeah, the poll is there in front of you. Kindly answer. Limited time once again. Last 5 seconds. Sharing the results. To check the health of a file system, we use this fsck command. Okay, the third option is the correct option. fsck, file system check. Okay, so you mention this command and you mention a path. It will check, the health of the file system under that path. All right. So I'm stopping the sharing. Let's go back to our cluster here. Okay, let's use this command. We can use it like HDFS, fsck. Then I can mention a path, say I can mention the folder user to begin with. Okay, I'm checking, I want to check the health of the file system under this folder user. Okay, let's see what health it tells. So you see that its status is healthy. See the information. Okay, first of all, look at the top, connecting to name node via. You can see how it connects to the name node. Okay, so the localhost 9870, that it picks up that this path, and then it tells you that fsck was started by HD user from this for path /user at Thursday, and time and all is there. Then we have only one data node, just a single node cluster. There's only one RAG, one data node, and total directories under this, that is 19. Under the user folder, it says total directories are 19. Okay, and total files are 40. Okay, total blocks are 26. So there's no problem with the clusters. Okay, there's no missing internal blocks, no missing replicas, because we have a single node cluster and we have kept the replication factor at 1. So nothing is wrong here. Okay, you can go below the user folder, or what you can do is you can go below. Let's check it under this. There would be lesser directories. We can check, match it here. So what we have here is now, okay, yeah, one thing we learned, that if we go below user HD user, then directories below user are also counted. So there's not much difference in the, the number of directories or the files. Only one has changed. Okay, so you can use this. If I do something, let me just put something wrong here now. Let's see here. Have a look at it again. Let's go with the root now. Okay, so that we can finalize how the health can go bad. Okay, look here, kindly look here. I'm highlighting the thing. right now there is no missing replica, no missing blocks, no corrupt blocks, and no missing replicas. Missing replicas come when, say, in our single node cluster, you are trying to take a replication factor of 2. Okay, so obviously it cannot replicate because it's a single node cluster, there is only one data node, so then it would give you a trouble. Okay, so this we'll discuss, okay, right now. So I need somebody to join me in that discussion. Raise your hands. I need to have a discussion on this, whatever I've said. That is how to check the missing replicas, how it comes into picture. So let me see who can help me with the discussion. I'll put the question once you raise your hand. Nobody is willing? Okay. Yes, Ritika.
Yes, sir.
Ritika, help me to change the replication factor to say, or where to check this replication factor? What I've set, what is the configuration file for this?
So we can check in HDFS site.xml.
Okay. What is the path for that? The default
User
folder?
local Hadoop.
Okay. This I think would work, right? This is our HDFS site. You can see the path. Now here we have said dfs.replication is 1. So we have stated the replication as 1. So whatever blocks are created, they are just replicated once. And there is only one data node, so no problem with that. Okay. Block size we have mentioned here as 2 MB. Remember, and then remember the folders we saw, the name node and data node. You can see that the path is this: user local Hadoop store HDFS name node, and similarly user local Hadoop store HDFS data node. Okay. Now what I want to discuss with you all is, I want to set the replication factor for some file. Say let's list the files. There is a checksum file should be there, or have we deleted it? Yeah, we have deleted it. Okay. There is a file mary.txt which is not there in your cluster, I suppose. Ritika, you stay with me. There is no file mary.txt here. We'll copy it there, okay? But with the replication factor of 5, okay? With the replication factor of 5, okay? Ritika, help me.
So Hadoop fs -put.
Okay.
Mary. So,
okay. In the root, okay? We have done that. So we can see that the file is here now. We'll just update our cluster. We can see that mary.txt file has appeared here, right? Ritika, let's change its replication factor. Right now it is 1. You can see here. Replication factor is 1. Let's change
yes,
it to 5. Let's change it to 5.
Hadoop fs -set rep -r.
Not needed.
No,
not needed.
yes. 5. Then /mary.txt.
Okay, we are here, set rep. Now we are setting the replication factor for this file mary.txt to 5. Okay, it will tell you the replication set to 5. Okay, replication 5 set. Okay, look here now. I'll refresh this. Right now it is 1. It is showing 1. Once I refresh it, it will show 5. I think all of you can see it in the cluster. Okay. Thank you, Ritika. Thank you.
Thank you, sir.
This replication factor 5. Now let's come to our again this the checking of the this. Let's check it again. So can somebody suggest what will change now in the health? Will there be missing replicas? Will there be corrupt blocks? What will be there? Raise your hands to answer this question. And how many missing blocks if they are going to be there? Okay, Mani has raised the hand. Yes, Mani.
Some missing replicas will be there.
How many?
4.
4. Okay. Right, let's check it like Mani has said. So we'll have the, yeah. See now, can you see here all of you? See, you have a single node cluster, one data node. You cannot have 5 replicas. You can have just 1 replica. So 4 are missing. 4 replicas are missing. The status again would be healthy, because it would be unhealthy when you have some corruption in the blocks, when the blocks, some checksum problem is there, then it would be a problem here. Otherwise it would be healthy here. But the status right now is that you said set replication to 5, it is not possible. Okay, and it will show you the blocks also which were not possible. You can see the blocks here. See, under replicated this block pool ID, this block 5567. Okay, 5567 is this block ID. Okay, target replica is 5 but found 1 live replica. Okay, so that is why 4 are missing. And if you go here and you just click on this mary.txt, you will see this ID here. Was it mary dot this? Just a second. Yeah, mary.txt. Okay, this block 1073746391. You can see it here. Okay, you set a replication of 5. Okay, and its generation stamp is 5567, the time. Okay, so you can see it here, the generation stamp is here after that. That is how it picks up the replicas. It says that it is not possible to have 5 replicas, only 1 live replica is there, so that is why 4 missing replicas are there. Okay, so this way you can you can use your fsck command. I hope it's clear once again. Okay, set rep is also clear. So one last poll, then we'll discuss some further topics with you. So putting the poll in front of you now. Should be an easy one for you. Just be careful while you're answering. The time is limited. Okay, last 5 seconds. We want quick answer from you. That's very easy. So close the poll. I'm sharing the results with you. The correct answer is the third one. Set rep is a single word, so all lowercase. 4 people have answered the first option, that is incorrect. 2 people have answered the second option, that is again incorrect. So set rep, the third option, is the correct answer. 81% of you have given it the right answer. Thank you. Okay, let's now see a few configuration files. Okay, so as I told you, all the configuration files are present in this folder. First you go to your Hadoop installation folder. This is your Hadoop installation folder. Okay, user local Hadoop. Within that there is an etc folder, and under that there is again a Hadoop folder. So this is the path. If you list the files here, you will see all your XML files, the configuration files, whether it is HDFS site.xml, whether it is MapRed site, whether it is core site. Okay, so let's pick up a file. Just review all the configuration files. Let's pick up a file, core site.xml. Okay, yeah. Okay, this is the core site file. You can see here, you see in a configuration file you have a property and then you have a corresponding name value sort of thing for that. So a property name is hadoop.tmp.directory and its value is this. That means all the temporary directories, they would be a part they would be all be in this temp directory. You set it up, right? Then the name node, your name node address is this, HDFS localhost 54310. For version 3 and onwards, you can set it as 9000 also, but I've set it just like this. And there's no problem with this number also. Okay. So let's see whether it works or not, whether we can access our name node with this HDFS localhost 54310. Let's check it and then we'll come to the trash configuration. Okay. I'll close this file here. Okay. So yeah, we were checking this. So I'll again make it, just come back to my home. Okay, and use this command, hadoop fs -ls. Okay, I'm listing all the files. And then I'm giving an explicit path here, okay, like the one we saw there. Okay, so can somebody tell me what this thing will show? What this thing will show? Hadoop FS -ls. What it will it list something? Okay, Ritika.
So it will display all the files from the home directory of HD user of the cluster.
Okay, let's see. So it is our home directory, the user HD user. Because you configured this as your name node address, so you can use this also. Okay. And if you want to see the root, okay, then this followed by a slash. This will list all the files in the root of your cluster. Now I need to go again. Yeah. So let's use this. See now, we have used this property. Now let's discuss this trash. Okay. So trash is, something like a recycle bin of your Windows or the trash of your Ubuntu Linux system. There is a trash in your HDFS also. Okay. It needs to be configured actually. So once you delete something, okay, then it goes to trash if the trash has been configured. Okay. If the trash has not been configured, then it won't work. And trash is configured once you set these two properties in your core site.xml file. If these two properties are not mentioned here, then you won't be able to access your trash folder. Okay. So these two properties are, first one is the fs.trash.interval property. Its value is in minutes. So you mention a value, we have mentioned a value of 3 minutes for this property. Similarly, there is a property fs.trash.checkpoint.interval. We have mentioned a time period of 1 minute for this. What are their meanings? Let's see it through an example. Okay, let's take up an example to understand these things. Let's come back to and let's see. Let's delete this mary.txt file. Okay, I'm going to delete this file from my HDFS. So for removing, again we have the rm command. Okay, then I can mention this. Okay, read the instruction that comes on the screen. So it says that it has moved this mary.txt to trash. Okay, from your localhost below the root, it has moved it to this trash. Okay, you can see the trash address also. It is user HD user, right? And there is a current folder which it is picking. Okay, so let's go to our trash. Let's go to user, HD user, and then the trash folder. You can see a current folder here. If I click on current, there is a file mary.txt. Okay, now this current folder stays only for the checkpoint interval that you've given. After that, it will be converted into a date time folder. Right now it is current, and if you just refresh it now, it will be changed to a date time folder. So a checkpoint has been created on 5th November 2020 at 11:03. Okay, can somebody suggest now at what time the file mary.txt would be removed from the trash? You can see the configuration here. Can somebody tell me at what time of the clock would it be removed from the cluster, this file mary.txt from our trash, right? Okay, Rahul, you can answer.
Sir, it's removed from the at 11:04 or 11:05.
11:04 or 11:05. Okay.
Yes.
Okay, let's hear from Mani.
Sir, it will move from 11:05 at 11:05.
At 11:05. Let's hear from Ritika.
So it will be removed at 11:06.
Okay, so 3 people with 3 different answers. You see, one says 11:03 or 4, one says 11:04, one says 11:05, right? Sorry, Mani says 5 and Ritika says 6. So let's wait for it first, and then we can have a discussion. So meanwhile, let's work with some other configuration file. We'll come at 11.6 here. We'll come back here. So let me open up another configuration file for you. You've configured all these files. Oh yeah, let's see the basic bash rc file. You remember the bash rc file? Okay, sort of an automatically executed 11.5 हो गए हैं. चलें इधर जरा देखें. मनी ने हमें 11.5 बोला था. मनी इसको कर रहा हूँ ट्रैश को. मनी इट्स स्टिल देयर. ओके 11.3 पे ये हुआ था. So इसका मतलब क्या है मनी? And others also answered that once you have a folder like this, a date time folder, after that whatever interval you have set in your trash, we have set it 3, so it would be added here. So 11.3 and 11.6 this file would be removed from here. Right now it is there in the trash, you can see, but as soon as the clock will strike 11.6 it would be removed. Let's wait for that. Mani, you just wait. I'll come back to you. I think you want to ask something, but let's first wait for 11.6. Okay. It is still 11.5. Okay. Yeah. You're seeing this .bash rc file. We'll come to it. Okay. And let's see if 11.6. Yeah, 11.6 is there. Let's see the trash now. You see it's gone. Okay, the file is now gone. That folder is gone, and with that the file is also gone. Okay, and let's come back to Mani. He wants to say something. Yes, Mani.
Sir, actually, I guess that at 11.3, that current folder converted into daytime. And sir, we have configured that file with the 3 checkpoint. And sir, I guess at 11.3, it is converted into daytime, and after 2 minutes more, it will be removed.
No, it's like this. Once a date time folder is created, after that whatever is the interval, it would be there. The checkpoint will just check after every minute whether the file has been removed or not. Okay, got it?
Okay, sir. Thank you.
Okay, so we were talking about this bash rc file. So whatever you have in this bash rc file, Rahul wants to say something. Yeah. Yes, Rahul.
सर जो उसका फाइल इंटरवल का सर वो टाइम स्टार्ट होता है टाइम इंटरवल अब जब उसको हम ट्रैश में से रिमूव करते हैं तब स्टार्ट होता है कि जब हम उसको डे टाइम फोल्डर में डे टाइम में से फॉर्मेट कन्वर्ट करते हैं तो
डेट टाइम में जब होता है तब. You've just seen it. We deleted it. Let's go do it once again. Just wait. You stay with me, Rahul. पहले एक बारी टाइम देख ले. 11:07 हुए हैं अभी. ठीक है. वो नई फाइल रिलीट करनी पड़ेगी अब. department.txt डिलीट कर देते हैं. ठीक है. 11:08 हो गए. Let's do it. So 11.806. ठीक है. इसके ऊपर हमने की है. ओके. तो 11.9 तक. Okay, remember 11.9 तक it would be the current folder. Remember, there would be a current folder till 11.9. You can see the current folder. Okay. इसमें ये फाइल department.txt पड़ी हुई है. ठीक है. जैसे 11.9 होंगे ये current folder जो है, okay, ये date time folder में convert हो जाएगा at 11.9. Let's wait for that so that you can see the exact. It is, you know, अगर 11.852 भी हुए हैं तो 11.9 पे ये करंट से उसमें चेंज हो जाएगा. ऐसा नहीं कि 1 मिनट पूरा है. नो, यू गॉट माय पॉइंट. 11.806 हुआ था ना, जैसे ही 11.9 होगा तो उसी टाइम ये चेंज हो जाएगा. हम 11.9 पे मैं एंटर करूंगा. ठीक है. अब देखना, इट वोंट वेट फॉर 11.906. ये हुआ, ये चेंज हो गया. सो ठीक है. अब 3 मिनट के बाद ये जो स्टैंप लगी यहाँ 1109 की स्टैंप लगी यहाँ पर. ठीक है. अब उस इंटरवल 3 मिनट्स के बाद ये यहाँ से निकल जाएगा. इज दैट फाइन? अंडरस्टूड? ओके, फाइन.
ओके, थैंक यू सर.
Okay. So I was talking about this your bash file. So whatever changes you make here, once you refresh them, then so you're mentioning all your Hadoop and the pig configurations here, where the folders are there, the install folder, the path, whatever, And then you can see I've written an alias here also, alias cls is equal to clear. So you remember the alias command here. So your clear, cls would be equivalent to clear. Okay. So if I just save it, if I write here clear, it works. Okay. If I write here cls, it will work again because it is the nickname for my clear command. This is what I discussed. This is the .bash rc file. Okay. Let's now look for some other configuration file. Let's see which other files can be taken up. Let's see this hadoop -env.sh file, what's there in it. Okay, so that all these files are refreshed that you've installed yourself. The wrong name here, sh. So here you remember you give the Java home wherever your Java is located. Java is the the requirement for your Hadoop. So you just mention where your Java home is there in this hadoop-env.sh file. All right. Then let's look for HDFS site we have seen. Let's look for MapRed site maybe. Let's look for a MapRed site file. Okay. And here you have, for your job tracker, that is your processing part. You just mention the value for your mapred.job.tracker. Okay, the host and the port that the MapReduce job tracker runs at. Okay, so for your pig, all your pig jobs are converted into MapReduce jobs. So for all your pig related queries, this property and value, the property name and the value would come handy while you are doing the analytics while using this MapReduce as the backbone and the pig at the front while you're using. So this file would be used there. Remember this. Okay. So I think I have discussed a few things with you now. There are other commands also. The safe mode, one safe mode we can discuss while we were starting the cluster. If you remember, like if you are here, then you can have see the startup progress here. All of you look at the screen, you can see the startup progress. Okay, so initially we discussed fs image. So you see initial your fs image is loaded, that is your cluster, entire cluster, the permanent file. Okay, and when it is loaded, then the edits file is loaded. Okay, then your edit file is loaded. I'll show you these files also in your name node folder. We'll go to name node folder after some time. I'll show you these files there. And then there is something known as a checkpoint. Okay, checkpoint is like when both these files are merged. So initially you have something known as a safe mode also. Whenever your cluster is started, for some period of time your name node is in safe mode, and it checks the status. It validates that whatever blocks are there, they are still there. Whatever blocks are present in the metadata, whether they are there in the data nodes or not. So that checking puts that name node in the safe mode, where it is not allowing you to insert or delete. And you can only read the files during the safe mode. And once the name node is out of safe mode, then obviously you can work with your insertions and deletions also. Okay, so this is the startup progress of your cluster. So you've seen that in the starting up, your cluster was in safe mode for 38 seconds. Okay, so I put you this question in your exam also, that for how long it is there. So this time is not fixed. If the number of blocks is more, it needs to validate a fixed percentage of blocks, only then it can come out of safe mode. So this time is dependent on once the requisite number of blocks have been validated, whatever have been set up in its configuration. All right, so let's now see how we can see this feature here. Let's go here, and I'll just write here Hadoop, or rather it's a admin command. So Hadoop HDFS DFS admin hyphen safe mode get. So I'm just trying to see what is the status of the safe mode currently in my cluster. So you can see the safe mode is off right now. Okay, so you can do insertions and deletions. If I want to make my name node to enter the safe mode, so I can write here enter. So now it will say safe mode is on. Okay, it will say safe mode is on. If I want it to come out of the safe mode, I can use a leave option here. So get, enter and leave. Okay, so now again safe mode is off. Okay, I'll show you what happens, whether you can insert or you cannot insert. We'll see that. Now let's see the files related to this. Okay, let's again come to this, look for computer, look for our default folder. Let's go to name node. Let's go to current. So you can see all the edits files. Okay, so whenever you start your cluster, a new edits file is there, changes are recorded there. Okay, and right now we are using the cluster, so there would be a edits in progress file. Okay, these are all old edits files, right? Let's look for edits in progress file. You can see it here, right? Can you see it here? Edits in progress. So currently whatever we are doing is being recorded in this file. Okay, and then it would be merged with your fs image file. Okay, fs image has also got many versions, but one final version, once the checkpoint is there, is there. Okay, so if you just click on it, edits in progress. Okay, the file is of, because it is that is the thing that you cannot see, edit this file, because it's an important cluster file. Okay, now let's see the safe mode part. Now what I'll do is have a good look how we can check this. I'll just stop all the services, right? I'll stop the distributed file system services. That is, I'll close this distributed file system. Now it won't be accessible. Okay, once I've closed it, and if you try to access that localhost 9870, obviously if I just start it again, let me try, it won't say, it will say that it is unable to connect, because there is no distributed file system now, because the services which connect you from local to distributed, they are not active now. Okay, so what I'm going to do is I'm going to start those services. Okay, but before that, let's look for a few files. We'll copy this file examples.desktop to the distributed file system once these services they start. Okay, I'm starting the services now. Remember, after the services have started, we'll try to copy this file examples.desktop into the distributed file system. I'm writing this. See, I'm trying to copy this file. Okay, see, cannot create file. It is not allowing you to insert the file into the distributed file system, because you saw that whenever the cluster starts, there's a fixed time in which it stays in safe mode. Previously it was 38 seconds. Okay, let's try it again. This command, if it is in safe mode, it won't allow, otherwise it would be copied. Still the name node is in safe mode. Okay, fine, let's try it again. Now it allows. Okay, so we can again go to our startup progress here. Now if I load it here, it would be fine. Okay, let's go to the startup progress, and again in this time it was there for 37 seconds, in which it didn't allow us to do anything with the cluster. Okay, so I hope you understood the safe mode concept here. Okay, right. Okay, so let's look here. Now we have seen the browser here. Okay, we have seen all the files. We have seen how we can, and you can see the permissions here also. Okay, the same are displayed in your command line also. Same are here also. Okay, and remember, for directories, the replication, the block size and the size are all 0, because directories don't have anything to store. They are just storing the other files. Their own size is 0. Okay. So now I will take some problems. I've discussed quite a few things in HDFS. Some commands are left. We'll have still a lot of sessions. We have some lab sessions also coming up. So it should be a good review. If you are willing to learn, I don't think anybody or anything can stop you from learning. And a quick revision of HDFS today, in which you've seen all these things, how we can work with the configuration files, how we can work with our cluster, how we can start and stop the services, what is the safe mode, what are the file transfer commands, how can we remove the files, what is the trash configuration, how we can handle it. So we have discussed all these things. I'll be putting up this video today, maybe in half an hour's time so you can again view it and you can revise it, right? So if you have any problems, you can ask now. I'm waiting for your questions. Some of you write that, I get messages from you. I try to reply to the messages in the fastest possible way. But some of you are asking questions, which I've already discussed with you. For example, you say that pig is not working, right? So I've told you how it should work. If it is, giving you trouble, you reinstall it using some different folder name. That is the only solution for that. Otherwise, you troubleshoot the problem, because if it is working fine for some time and then it stops working, that means something wrong is there at your end. You must rectify that. Okay, let me ask one. Okay, so I'll close this session here. Okay, I'm just stopping the recording.